I would like to talk a little bit about the pathway of oxygen and specifically the movement of oxygen by the differences in partial pressures of gases or partial pressure of a gas. So the partial pressure of a gas, the definition is that each gas in a mixture exerts a portion of the total pressure of the gas. So air is a mixture of a bunch of different gases, and oxygen, mainly nitrogen, some carbon dioxide. So the partial, the component of just oxygen can be thought of the partial pressure of oxygen, or the PO2. And to calculate this out, it is simply the percent of oxygen in room air expressed as a decimal. So 20.93% expressed as a decimal or a fraction is 0.2093. And then that is multiplied by the total air pressure. The total air pressure at sea level is typically 760 millimeters of mercury. So if you multiply those two together, it's 0.2093 times 760, or a PO2, a partial pressure of oxygen in room air at sea level of about 159 millimeters of mercury. And gases want to go from a high to a low partial pressure. So this is what it is in room air, 159, and it's obviously going to be less than that as we go into the trachea, into the lungs, and into the circulation, and finally oxygen gets into the cells and into the mitochondria. So this is the equation for partial pressures of a gas, and you should be able to calculate this out at different at different total pressures of air, so different air pressures.